we're continuing the lesson about factoring the polynomials when the first term is not 1. Anton, what's the first thing we should check for?
The number there that has a number, not like if it's just 1 or 4.
Okay, if it's 1 or another number, we should also check to see if there's anything in common. Good. So there's nothing in common here. There's nothing that goes into 4, 19, and 21. So that means, Jonathan, what do we do to start?
We make the little factor thing.
We do make the factor thing, but what is the number that we're going to factor? How do we find that, Charles?
21.
You multiply -4 is -21.
Good. So we take -4 times -21, and that's going to give us
81. I mean 84.
84. So 84 is the number that we're going to factor. We're going to find the factors of 84. So, you know what? Let's go down and we're going to do this systematically. Okay? First one, 1 and 84.
85.
Gives you 85. That's not what we're looking for.
Nope.
How about, does 2 go into 84?
Yeah.
Goes in 42 times. That's not 19 either. It's 44.
Isn't it like 20?
Okay, does 3 go into 84?
No, it's not all.
3 does, and it equals 28. 3 times 28, but that's also not our right answer, is it?
Nope.
We're getting close to 25.
We are getting closer, so that's helpful. 4 goes in
21.
21 times, and again, that's not quite it, but once again, we're closing in on it.
Should be this one.
5.
No.
No, how about 6?
6.
6 times
A number.
4. Is it 14?
Well,
Yeah,
that was a
6
good
times
behind
14
guess.
Yeah.
gives us 20.
20.
So that's not it.
Oh,
It's
But what about 7?
Oh yeah.
7 times 12,
Yeah. There it is.
and there it is. So it took us a little while to get there,
yeah.
but that particular factor combination probably didn't just jump in from the beginning. So the fact that we went in a systematic way helped you to actually find it.
Yeah.
All right, so now we need to break this down into its parts. We need to take 4c squared. What do I do with the 7 and 12?
You separate it. You
Good.
plus
Plus 7c
plus 12.
plus 12.
See?
Okay, I didn't see any. It's all right, it'll still work. Minus 21. All right, so now we look for the things in common here, and we look for the things in common here. All right, so what's in common on this one?
I see.
C.
So you pull
Just C.
Just pull out.
C times -4
C
C
plus 7.
plus 7.
Awesome.
And
That's
then
right.
what
Shut up.
is in common here?
Oh, that's what I
One.
Let me tell you.
Yeah.
2, oh, 0.
3.
6,
Oh
7,
yeah, 3.
7.
3.
7.
7.
Okay.
3.
7.
7 can go into 12.
7 doesn't go to 12.
7 not going to 12.
3.
At the end of the
Sorry.
power.
It's
What?
three.
Yeah, four.
Sorry, 3.
3.
3 times 4C.
Minus 7.
Minus 7.
All right, we have a problem.
That doesn't work.
What's the problem?
You can just switch it
Negative.
times.
C plus 3.
Okay.
that's what I was.
All right, listen.
Or divide by
Listen to me.
negative
Alright.
1. Yeah, divide by negative 1.
I need all the little chatter to stop. Okay? Because some of you were just so automatic. Look what happened here. This is almost matching. It's not quite matching. However, listen to me. Here's where you have to be a little bit careful. This can happen sometimes. Really, the only difference is that the signs are backwards. So instead of factoring out a regular 3 here, we could factor out a -3, and that'll solve our problem. But negative 3 times negative 4c gives you positive 12. Negative 3 times positive 7 gives you
A negative 20.
negative 21. The reason we did that is because these can't even be a little bit different. They have to match completely. So if you look and you say, wait, it almost matches. See if the only thing, see if changing the thing you factored out to a negative will fix your problem. Okay? That's what makes this one a little bit trickier. Okay, is that little hidden thing that you have to do with the negative. So watch out for that, especially, well, I'll tell you right now, if the only thing that's different is that your signs are backwards, you're going to have to do that little trick to fix it. Now, since they match exactly, okay, some of you are very quick to want to just jump on breaking it apart. Make sure they match exactly. Now we have c times negative 4c plus 7, and then a negative 3 times 4c plus 7. And this is our answer. Okay, this one is number 9 from your sheet. So that's just a little something. This is a big problem because you had to do a lot of breakdown as far as finding the right factors, and then that one little trick that I needed to make sure that I showed you. Okay? Is there anybody still writing?
Yes, I am.
Okay. Okay, almost got it.
Hold on.
Everybody else got it?
Hold on.
Projected voice.
I'm good.
Okay, good. All right. Let's take a look at this one. 6x squared minus 7x plus 18.
That's number 16.
Okay, nothing in common, so we need to take 6 times 18, right? This is number 16, by the way. So 6 times 18 is 108. So we're going to take the factors of 108 and add them. Now we have a negative in the middle, so we're looking for a negative times a negative, right?
Yeah.
Okay, so negative 1 times negative 108. Okay, now we know that that's way off, negative 109. Okay, negative 2, negative 54. Okay, now you'll take your time on your calculator to be able to do these. If you're not doing this as quickly in your head, don't worry about it. 3, negative 3 is negative 36. Now we are kind of closing in a little bit. Negative 39. Then we have negative 4 goes with 27. That's negative 31. Okay, I do have a purpose in showing this one. I know I'm writing a whole bunch. 6 goes in 18 times. And that gave gave 24.
Almost 25.
Okay, and then we go to 9. And that's 12. And that gives negative 21. Now the problem is if we try 10, 10 doesn't go in, 11 doesn't go in, 12 does go in, but it goes in 9 times. So what's going to happen is we're going to start having the repeats. So this right here represents all of the possibilities. We never got the numbers to work. So if you tried all the possibilities, then that means that the thing is prime. So in other words, it's already factored. There's nothing more you can do with this one. There's nothing in common. You tried every single possibility. It can't be factored. So it's already factored as is, we call that prime.
So if we don't get past like 9 or like -9, then it's probably fine.
Well,
we don't get the
it's
number?
not a matter of just going past 9, it's a matter of the next one that actually goes in is 12. But you see how all it's doing is, if we keep going, all we're going to be doing is reversing the numbers. The next one that goes in is 18. Okay, see what's happening? It's just reversing them. So once I hit here, once I start having the repeats, I could go all the way up to 108, but it's kind of pointless because you see, you're just reversing the numbers once you get past the middle point, and the middle point is where that second number becomes bigger than the first number. Okay, I say bigger because I'm thinking absolute value instead of actual.
Can we do number 3?
Number 3, sure. Let's do number 3. Let's see. 16r squared minus 8r plus 1. Okay, so the first term there's nothing that goes into all of them, so we multiply what and what?
16 and 1.
16 and 1, so we get 16. We're going to factor 16. Alright, so let's try. Now, are we going to do the positives and negatives? What are we going to do?
Negative.
Negatives, so let's try -1 times how much?
-17.
Okay, so that's -17.
Oh.
How about 2?
-4, -4.
8.
So
No,
that's
-1.
not it. How about 3? No, 3 doesn't go in. How about 4?
-4, -4.
What that gives you? Oh, yeah. That gives you a positive. Yeah.
Okay, so we got it.
Oh, yeah, you're adding, right.
So we break it down like this. You have 16r squared minus 4r
-1.
minus 4r plus 1. Okay. Factor by grouping. It's what's in common? 2 are more. 4. 4r goes into both. 4 times 4 minus 1. Now, Philip, what might have been getting you is this is one of those that has something slightly unexpected in it. 4r plus 1, there's nothing in common there. However, we could do plus 1, but if we try plus 1, does it match exactly? No, so we have to do our little trick. What's our little trick? So we're factoring out a -1. So that makes this one positive and this one negative, and then it matches. So this is really 4r minus 1 times 4r minus 1. Now this one actually, not today, but tomorrow we're going to get into some special ones. This is actually a special case.
Why are we being special?
Okay, because we ended up having a binomial times itself. So this does turn out to be a special case. There'll be a special pattern I'll be able to use for that. We could do 4r minus 1. If you want to write it like this, you can. 4r minus 1 squared.
Okay.
Okay, either one of these is a correct answer. Okay, as far as factored form. Okay, now, one of the things that you're doing tonight is you're going to go and you're going to finish this worksheet, but we have the next topic, which is a little bit easier from worksheet 5, so you can have worksheet 5 handy. And we're going to pull up we're going to set it as a whole different topic. And it's called factoring the difference of two
And we
squares.
have a homework. Number 43.
Okay. Factoring the difference of two squares. We have two key words in here. We have difference. Alvin, what's difference mean?
Difference, subtraction.
Subtraction. And squares means
Two by two.
square. Two's for the exponent.
Whatever.
Good. To the second power.
Factors.
So when you're trying to factor the difference of two squares, this is not a trinomial anymore, it's a binomial. It's a special type of binomial. Okay, the directions for everything we're going to do today are factor completely, just in case you need to write that down. You always start when you're factoring to see if there's anything in common. So I just put this little disclaimer, you know to do this, but this is not new information. But Jonathan, I need you to always remember to check to see if there's anything in common first. And then you check to see if, number one, it's a difference, because we're talking about the difference of two squares. And number two, you need to check to see if each term is a square, because we can't use the difference of two squares method if you don't have a difference and it's not two perfect squares. Okay, a perfect square, Preston, you know what a perfect square is? Oh, okay.
Yeah.
Not a regular,
I don't
so
know
you're
why.
thinking geometry.
Yeah, I don't know why
Okay,
you're asking.
for example, a perfect square number.
Oh,
2 squared, which gives you 4. So 4 is a perfect square. 5 squared, which is
25.
25. 25 is a perfect square. Anywhere, any number with a square root that comes out. Okay, so can you give me another one, Julia?
My mom? Or no, 6 times 6, 36.
36. Good.
Or like 25 would
36.
be 6, 25.
25. 625 is
14.
25 times 25, not 14. 14 is not a number times itself. All right.
Oh no, forget that.
Grace, however,
Oh, 49.
49, which is 7 times
Did I
7.
say that? Did I
Good.
say that already?
All right, so here's an example. This one
1187.
is the, all right, I should see more people writing things down.
Right.
Everybody needs to be writing things down so that you can understand when you go back later, and some of the people who are talking are the ones who aren't writing things down. So you need to make sure you save yourself in 2 ways. Number 1, you need to understand. Number 2, you need to not distract others. So x squared minus 25. This one's a perfect square, it's x times x. This one's a perfect square, it's 5 times 5. So that means we're going to be able to factor it in a special way.
Yes.
All I'm doing is,
Love that.
here's our x squared minus 25. If it turns out to be the difference of two squares,
Wait, what was the
What
step
happened to the other?
The step 2 for that one?
we're not even up to step 1 yet.
No, I mean from the prior page, the one that says it is a difference, and then each term is a difference.
Each term is a perfect square.
Okay.
So the first thing, you're just checking to see if it's the difference of two squares. Okay? So we check to see. X squared is x times x. 25 is 5 times 5. So we know that we have something in that category. Once you know it's in the category, okay, we're going to follow these simple steps. Okay, step 1. You identify what is squared in each term. So what thing for this term right here, what is actually squared?
The X.
X. What here is squared? 5. So we write it out like this. X is squared and 5 is squared. You're probably not going to actually write this step. Okay? But I'm showing you as a step so you know what, when you look at your notes, you know what the thought process is. So this is x times x. This is 5 times 5. Now, the second step is to break it into the product of two binomials. It really becomes, you take the The first ones, they go in the beginning. That second thing that's squared goes in the end, and you put in a plus and a minus. Okay, it's a very simple thing. You find out what is squared, you put them on both ends of a binomial, and make a plus and a minus.
Minus B.
Okay? Now, what we can do is we can check this. Okay, this next slide is nothing
No.
there. It just added check by multiplying. Okay. I didn't get rid of anything. All right, so we're going to check this thing by multiplying. So let's do x plus 5 times x minus 5. So the first terms is x squared. The outer terms is,
Negative 5x.
the inner terms is
Plus 5x.
plus 5x. And the last terms is minus
Negative
25. What happens here?
They cancel.
Negative
Cancel
5
out.
and positive 5 cancel out, so we have x squared minus 25. That's why this plus minus thing works. Okay? That is why the plus minus thing works.
Okay, you spoiled it. Okay, I got it.
So this is the check. This is your answer right here. X plus 5, x minus 5. What did I Alright, so in general, this is what it looks like. If you have the difference of two squares, whatever it is that's squared in the front and whatever it is that's squared in the back get turned into a binomial, a plus b and a minus b. Okay, so it's a pretty simple process. The hardest thing is figuring out what's squared. Okay? So we have a second one to look here, because it's not always just real simple where you've got one variable, one number. We're going to check first of all, is there anything in common? No, nothing in common. However, is it a difference of two squares?
Yeah.
Yes, it's a difference, but we need to figure out what is multiplied times itself here on the front end. M and what else? 2. 2m times 2m is 4m squared, right?
Correct.
2m times 2m is 2m squared. The other part, what times itself gives you 81, 9, and an n. Okay, 9 times 9 is 81. N times n is n squared. So we do have a difference of two squares. Our two things that are squared are 2m and 9n.
Right.
So in this case, we have variables that come with it, and you have to look for the complete thing that was squared. So this becomes 2m plus what? 9n times 2m minus 9n. Right?
So that's the answer?
This is the answer. Now, I'm looking at the time. It was important for us to take our time and finish the other lesson. It's important for us to do a good job on this. You're going to put off finishing this worksheet because we need to finish this lesson. So tomorrow we'll finish this lesson. However, 8.4 is due tomorrow. Worksheet 8.4 is due tomorrow.